video on fractions to review the notes for the week that we talked about. So to start off, we talked this week about 4.NF.5, which is talking about understanding the new place value with the tenths, the hundreds, and the thousands. Now we learned that, like how you have a hundreds block, it looks kind of like that. You have a tens block, which is like a bunch of tens, and then you have a ones block. Well, with fractions, it gets smaller than that. So it's like everything starts being like little snippets and sections, and it gets smaller and smaller and smaller. So to begin, let me write the place value chart in order to understand this. And you could also type in YouTube this exact standard 4.NF.5, and you will see videos that also explain this. So we do the place value chart, and I say ones. After that, you got tens, hundreds, thousands, 10,000s, 100,000s, and if you kept going, and then you would have 1 million. And in 5th grade, they'll have to do the powers of 10. Now, the power of 10 really indicates how many zeros. So this is 10 to the 0 power because 1 has 0. It has no zeros. But 10 to the first power, that's 1 with 1 0 at the end. This is 1 with 2 zeros. So that's getting bigger and bigger towards the left. Now, with decimals, which is what we're talking about this week, which is all about decimals and fractions within the powers of 10. So it gets smaller. That decimal's there. After that, you have the tenths, and then you have the hundreds, and then you have the thousands. So this is all part of a place value chart, and you can actually keep going. You're either going to be dividing by more and more zeros, or you're going to be multiplying by more and more zeros. Now, and like I said, if it's going towards the right, it would be smaller. If it's going towards the left, it gets bigger and bigger and bigger. So now to dive right in, we talked about, like, for example, 6/10. If we turn that into a decimal, I'll show the easiest way for the sake of the video is the jumps. So you drop your numerator. That's step 1. Drop your numerator. Step 2. Put your decimal, and then step 3, do your jumps. Now I see I have only 1 0 right here. So since I have 1 0, that means I'm going to do 1 jump backwards to make it smaller. Because if I were to do a jump forward, that would make the number 60. If I do 2 jumps forward, that would make it 600. Well, since we're dividing, we're not going to multiply. We're actually going to make it smaller, so we're going to have to do a jump backwards. And we're going to end up making that decimal be right here instead. So the answer is 0.6. If I said 600ths, remember, put the numerator, drop that decimal, and since I see 2 zeros, I'm going to do 1, 2 jumps, and the answer is 0.06. And if you also look at the place value, you can say its name. That's another way. Saying the name, saying the place value. So I'll show you. I would say this is in the tenths place, and this is in the hundreds place. And you say the name of the last value. So this is equal to 600ths. Do you see how the name would actually sound exactly how it would look as a fraction? This is in the tenths place because right after the ones is you have the tenths, and then the hundreds, and then the thousands. So that's equal to 6/10. So likewise, if I said 0.05, I can say the place value. I know this is the tenths, hundreds, and this looks just like the place value, and thousands. That means that 5 is really equal to 5 thousands. It looks exactly how it sounds as a fraction. Now, we can also use multi-digit numbers as well for this. If I said 51 hundredths, you would stick 51 because that's your numerator. You stick your entire numerator down, stick your decimal, and I see 1, 2 zeros. That means I'm going to do 2 jumps back. 1, 2. Remember, every 0 is a jump. So the answer is really 0.51. If I said 623 tenths, that's very easy. I'm dividing by 10, obviously. So what I'm going to do, drop my whole numerator, not part of it, the whole thing, put the decimal. I see 1 0, so I do 1 jump. So the answer is 62.3. So 4.NF.5 is all about talking about fractions and decimals. Now, another thing that you will see with 4.NF.5 is using fraction models. So, for example, if I said, I'm just going to try to draw a block here, and I go, so what I'm trying to do is make a 10, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically that's a hundredths block. Now if I were to leave it with the regular fraction model, 1, 2, that's the tens block because I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the denominator would be 10, and I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 on both, so that 10 times 10 is 100. And in thousands is actually even smaller than that. But typically on a state test, they don't show that. Now, we're talking about a shaded amount. Let's just say we got this row, that row, this row, and then 1, 2, 3, 4. Well, you also need to be able to identify what this is showing you, right? So I would say I can actually count 10. I got 10, 20, 30, and I can't say 40 because the whole thing is not filled. So I got 30 plus 1, 2, 3, 4. So the answer is 34 hundredths. Here, if I said 1, 2, 3, the answer is equal to 3 tenths. So that is basically that in a nutshell. Now, I do want to discuss 4.NF.6 because we talked about that as well. And this is talking about adding or subtracting your tenths and your hundredths. Or you can even apply this to thousands. Now, if I said 6 tenths plus 4 hundredths, the red flag happens because I can't add straight about because my denominators are different, right? This has 10, that has 100. So what I'm going to have to do is I tell my students add a 0 on top and bottom of the smaller denominator. And since 10 is smaller, we can stick the extra 0, and we're going to do the same on top and bottom. So when I stick that extra 0, that means I'm able to go ahead and fluently add. And the denominator is going to stay the same. And 60 plus 4 is 64. And you know as a fraction, decimal, the answer would be 0.64, 64 hundredths. Now, I'll show another one. And I can see here, this has 3 zeros, that has none, right? Well, 2. I'm going to need an extra 0. I'm not going to stick it here because I have to stick it on top and bottom, and we don't need an extra 0. So here I can stick it on top and bottom to make them have the same denominator. And so my denominator would stay the same, and 50 plus 6 is 56. Likewise, when you subtract, you would have the same method that applies. I can say 7 tenths minus 40, hundreds. Again, I can't add any more zeros because this is the bigger one with zeros. It's already got enough, right? So now I would need a zero on this side. And when I add the zero on top and bottom, now it looks like 70. So 70 minus 40 is going to be 30, and my denominator stays the same. So the strategy is just add or stick a zero on top and bottom. And sometimes they will make you add, like for example, they might use something like this up here, and they might say, and use grids to add 14 hundredths plus 2 tenths. What is the sum? Well, the students would have to say 0 on top and bottom, because 10 is obviously the smaller one, so you would need an extra 0 on top and bottom, and now it would be 20 plus 14, which would be 34 over 100. Now you would have to choose the actual grid that matches that. This would be wrong because this has the wrong denominator. And then even if you can't have 34 when it comes to tenths. Here, obviously, I got 10, 20, 30, and 1, 2, 3, 4. So that is 34 hundredths. All right, so that being said, I will go ahead and make the homework video, and that will be uploaded soon. Thank you for watching. And oh, no, I'm about to cut it off, and I got one more thing to talk about. Comparing decimals. Now, it is actually really simple, but I understand why students can get thrown off. So remember, we're going to compare using greater than, less than, or equal to. Now, I'm going to write, let's say, 2 tens, 100,000, 2 and 159 thousandths compared to 2 and 64. Now, if you were to stack it with the bigger value on top and bottom, or you can just stack these numbers. I'm going to look at the place value. I already know my places. We got the ones, because there's a decimal right here, so it's not the big. This is the ones place. After the decimal, you have the tenths, you have the hundredths, and then you have the thousands. So if I look here, this is the same, this is the same, but now I see a big difference, so I can use my hundredths place. And you got to see which is bigger, 5 or 6, and 6 should be bigger. Now I'm not going to worry about that 9 and that 4. It doesn't matter, because in this place, that's what matters, because this place is actually bigger than that place. So 6 is bigger than 5, which means that this is greater and that other number is less. So with fractions and decimals, the decimal can get smaller and smaller. So even if I had compared to 0. If you don't see anything there, take it as an imaginary 0. Nothing there means an imaginary 0, but at the same time, even though this has 1, 1, 1, and what if I had 9, 9, 9, and 8, 8? I can just keep going forever and ever and ever, and nothing will make this greater. The reason why is because this is the only place that matters. The ones place is the same. It both has a 0, but the tenths place, that's what matters, because in the hundredths place, I got a 0 here and a 1. I don't even have to worry about it, because 9 is greater than 8. So the answer, this is greater than the 8. All right, so that's about it. Again, remember, the alligator mouth eats the larger number. And that's it. Have a good day.